Alright, so this is sample E, question 14, another trig question. So we have two triangles in one big triangle here. They tell us this is 3, this is 53, and that's 30. Now let's just highlight what they're actually looking for. So work out the length of DC. So they want this guy. Now, it looks like, you know, it doesn't give you much information. So it's a little bit of problem solving. What we have to do is we have to see what we can work with. So I noticed this little triangle here on the left. So I can work out the length of this line here because that's common. And then I can work with this triangle separately. So let's have a look at just this guy on the left, and I'm just going to draw it separately for myself. So we have 3, we have 53 degrees in there, and we have x. Now, you know, can I figure that out? Well, that's right angled. Can I figure out the length of that? Well, yes, I can. Pythagoras won't do it for me. But if I use sine, cos, or tan, so I always write down sine, cos, tan. And if I say my poem to myself, oh hell, another hour of algebra. Right, and I need to figure out which one do I use. So I'm going to label my triangle here. So this is my angle. So opposite would be the x is O. This is the hypotenuse and this is the adjacent. So I need to choose something. The hypotenuse is useless here. I need x and I have 3. So I need something with O and A, which is tan. So I'm going to write down tan of the angle equals O over A. Now let's fill that in. So tan of 53 equals x over 3. Okay, I want to just get x by itself. So I'm going to multiply across by 3. We have 3 tan 53 equals x. I'm going to pop that into my calculator. 3 tan 53, and I get 3.98. Let's just do 2 decimal places. 3.98 equals x. Right, so I don't know if I'm going in the right direction yet. I've just figured out something that I could. Alright, so a little bit of problem solving, because there is no way to find x in this triangle here, in this right angle triangle. I did not have enough information. So I've had to find out something else. And now, finding that which is common, I now have a bit more information in this bigger triangle. So let's draw that big triangle and see if I can work with it yet. So I always draw my triangles. So this is 30, this is 3.98, and I don't have anything else. I know this is the right angle and this is what I'm looking for. Alright, so let's label. So this is O, this is A, and this is H. So the hypotenuse is always across from the right angle. So it's going to be sine, cos, and tan again. Pythagoras will not work. I don't have enough information for Pythagoras. So to find one of the sides, you'd need the other two. So it's going to be sine, cos, or tan. I already have it wrote down here, so let's work out what one I will need. So I need something with A, because that's what I'm looking for. That's the unknown. And I have O. So something with O and A is tan again. So I'm going to have tan A equals O over A, and let's fill in. Tan 30 equals 3.98 over x. Now that is what I'm looking for. So I need to isolate it. I need to get it by itself. So I'm going to first multiply everything by x. Get rid of that fraction. And I have have this. And then I need to get rid of tan 30. That's just a number, so I'm going to just divide by tan 30 on both sides. And I will have x equals, now I already have this from before, so I just need to have that number divided by tan 30. Pop that in there. And I get 6.8955. Let's just write that down. 6.8955. And it doesn't actually say how many decimal places. Let's just, so that would be correct. Let's just do one decimal place, just to make it look nicer. 6.9 meters. And that is it. Sorry, missing the end of it there. So 6.9.